Proof by induction here, this time concerning matrices. So we're given a matrix M, which is 2, 3, 0, 1, reading left to right, and the task is to prove that m raised to the power of n is given by this formula here. So again, like I said, we're going to use induction. So the base case is n equals 1, and plugging that in, we get 2, here we get 2 minus 1, so that's 3, 0, 1, so that's pretty clear that that's true. So our anchor step is to assume for some n equals k that mk is equal to 2 to the power of k, 3, 2 to the power of k, minus 1, 0, 1, and then our goal is to prove, using this assumption, that this is true for n equals k plus 1. So what would that mean if it was true? Well, what we're looking to show is that mk plus 1 is equal to 2k plus 1, 3 to the power 2 to the power of k plus 1, minus 1, 0, 1. So m to the power of k plus 1 is equal to m multiplied by m to the power of k, which by assumption is m, so 2, 3, 0, 1, multiplied by 2 to the k, 3, 2 to the k minus 1, 0, 1, and then multiplying this through. So the way matrix multiplication works is we go across the rows of the first matrix and then down the columns of the second one. So this first component here is 2 times 2 to the k plus 3 times 0. So that's 2k plus 1, which is looking good. So now this top right component is 2 multiplied by 3 2k minus 1 plus 3 times 1. So that's 2 times 3 2k minus 1 plus 3. Here we have 0 multiplied by 2k plus 1 multiplied by 0, so that's 0, that's all good. And then we have 0 multiplied by this term, and then plus 1 multiplied by 1. So all the terms are looking good, apart from this top right one's not quite in the form we want it in. So let's take a look at this. So here we're going to get, bringing this 2 inside, we're going to get 3 multiplied by 2k plus 1, and then we're going to get minus 2. So let's put that in. So we're going to get 3, 2k plus 1, minus 2, plus 3, and then if we just go up here, we're going to get, so all these other terms staying the same. Multiplying that out, we're going to get 3 multiplied by minus 2, which is minus 6, plus 3. So altogether we have 3, 2k plus 1, minus 3. So then if we factor 3 back out, we get 3, 2k plus 1, minus 1, and that is the result we were after.